Hi everyone, it is your SI leader, Julieta Torres, and today I'll be talking about solving high-degree polynomials, just what we went through class today. So for you who have a bit more confusing or didn't understand it quite well, we're going to do more of the graphing part. So let me give you an equation. Let's see, what did I write down? 2x cubed minus 2x squared minus 8 plus, minus 8x plus 8. So we have our, can you even see that? I think you can. Let me write it let me try writing it with a black marker. Seems like it got dried. Let's see. So our equation was 2x cubed minus 2x squared minus 8x plus 8. So we have our equation and we want to do it in a polynomial. More specifically, we want to graph it as well. Now, there's a lot of steps involving to graph this equation, more specifically the polynomial, but the more you practice, the more you get the hang of it. For now, let's do the most three important ones, or not really important ones, but the more easier to solve, which is the degree, leading coefficient, and the end behavior. So try to remember these three, remember them all. But remember that the degree is the highest exponential in your equation. So if you look here, our highest one is 3. So our degree is 3. Leading coefficient. Now, I've seen that a few of you got confused with this part, kind of, thinking that the leading coefficient is with the biggest number, like 8. But no, that is not the case. The leading coefficient goes with the degree. So if we found our highest degree, it's what basically the number in front of the x is. So for here, since our degree is 3, our leading coefficient is 2, positive 2. Now to find our behavior, if you go into section 6.3, it will give you the end behaviors, or how the graph will, if it will go up, down, like, is it up or down, or are both of them up, or both of them down? And the way to find it is either the degree is odd or even, and the leading coefficient is negative or positive. Now we can see here that our degree is 3. That makes it an odd number. Our leading coefficient, however, is 2 with no negative sign in front of it, making it positive. Now that we know enough, we can finally figure out what our end behavior is. So if it's odd, it will go down, and if it's positive, it'll go up. Okay. Now we're halfway there. We're almost there. You may be wondering how to remember the end behavior. How can I remember, like, what if it doesn't go down or up? I remember I had to struggle with this. I usually use my hands. If you're more of like a visual person or you need something to move, usually I would just say, okay, even and positive, odd and negative, or odd and positive, or even and negative. Just kind of throw in randoms and you usually get the hang of it. You're like, okay, if it's this way, it's going to look like that and like that, so it should be written like this. Now that we're halfway there, we need to find our x-intercepts, or our roots, this is also called. Our y-intercepts and our multiplicity. I'll just write a short word for mult. So we need these three as well to be able to graph it. When we graph it, it doesn't have to be exactly accurate, but it can be close enough where if someone were to graph this in a calculator and they see your graph, they can see, okay, it does go through the 3 main points and it has the end behavior. It's like the same graph. Now, usually what I usually go with the easiest one, meaning the y-intercept, because you make you plug in 0 as x, which is really easy, especially here since almost like all of them are x, so it'll be like 2 times 0 cube square minus 8x plus 8. Now that we plug in our x values as 0, well, it's not that hard. Almost all of these are number of 0 except for 8. Am I done here? No. You have to put it as a pair. Do not forget that. Trust me, I forgot, and you lose points. Try to remember it as a pair. Even for the x-intercept, also write as a pair. So x, those are your 8. That is our pair. Now, for usually our toughest ones are a little bit more confusing. It's our x-intercept. And I brought out a space here, so I'm going to write it down here. I'm going to put roots. Okay, how can we find our x-intercepts? As we can see in our equation, it does not come in a pair. It's like a full-on equation. But if you can notice, we have 4 different values, meaning we can divide it in half. So if we can divide it by half, we can see that, let me draw in a different color. Not easy when you have one hand available. Let's see here. Put that down. Let's hope this does not dry. I can draw this pair and this pair. So let's do 2x cubed minus 2x squared first, and then we'll do the other side. Because if you take your time, you usually do not get lost. So, what can we notice these pair have in common? We can tell that both 2 and x is very common. So we can put the outside as 2x squared, right? Because here's cubed and here's 2 squared. You can just have 2x squared. Parentheses x, because we need it to be a cube, and then -1, because multiplied by -1 will make it -2 squared. Now for our second pair, this was a little bit tough, even for me. I forgot. But take your time, kind of look through it. What could it be in the pair? At first I thought 2, but then I noticed that when I did that, both of my pairs did not equal together, and that was not correct. It could have been 4, but it's the same problem. And I noticed that both of them are 8, meaning I can just have 8 out here, meaning -8, parentheses, x, minus 1. Now we have it the same. Now we have the same pair, So let's minimize it. 2x squared minus 8 and x minus 1. That'll be easier now. X minus 1, that's really easy. Just x equals positive 1. We have one root. Now for x squared minus 2x squared minus 8, you can either solve it by making it equal to 0, or we can also factor it even more, because we can still plug in 2 here. Oh, not 8. But I usually like to do it the long way, because then I get lost right there. So let's make it equal to 0, 8, 0. We move 8 to the other side. And we divide by 2, because we want x by ourselves. We have x squared equals 4. Then we square root it. That goes away. X equals plus or minus 2. Now that we have 3 roots, remember that we have both a positive 2 and a negative 2. That equals 3 different types of x-intercepts or roots. So let's write it here. So we have x, we have 1, 0, 2, 0, negative 2, 0. Here it is. Those are our roots. Now for the multiplicity, the pretty toughy one, because you get a little lost. You want to go up here, but no. We don't want to look up there. Because remember, we had to put in parentheses. They didn't give us in parentheses. So since when we solved it for the x-intercept, we can see here that in our parentheses, none of them have a cube, a square, nothing. There's nothing here to indicate that you will go jump or do a wiggle. So if there's nothing we can see here when solving this, that can only mean that all of our roots are 1. So I'll just say 1. And there you go. We found every piece of information we needed to know to do our graph. Now, all we have to do is obviously graph it. I'll erase this since I wrote it down somewhere else, but let's see. Now then, let's draw a graph. That is the best graph I can do. Do not forget your arrows, because that indicates that it goes forever and ever. Now, let's see. We said that our y-intercept was 4, 8. All right, x-intercept was both 1, 0, 2, 0, and negative 2, 0. And our multiplicity was 1. And we both know that our graph goes down and up. Usually I like to put, when I find the end behavior and they give me a graph, and I usually like to put the end behavior already down, but you don't have to do that if it doesn't work for you. So let's see. Well, let's plug it in. So y-intercept is 8. So I guess 8 somewhere around here. Doesn't have to be accurate. X-intercept. We have -2 here. One and 2. And we know that it's 1, meaning they all go past each other. So let's see. It goes here, it goes here, and it goes there. Whoops. There we go. Do not forget your arrows, because in any case it goes on and on forever. And there you have it. That is how you graph a polynomial. It looks scary, it is a lot to remember, but if you at least remember that you need to find the y-intercept, the x-intercept, the multiplicities, and leading coefficient, degree, and the end behavior, you'll usually be fine. If you truly do not know, or you're like really hesitated when you figure this whole thing out, you're like, I'm not sure if this looks right, I mean, I did the math and everything, you have a calculator. You can plug in this equation and make your calculator do it for you. It will give you the graph. Of course, it won't give you all the answers and all the x-intercept. I'm pretty sure it can, but you're gonna have to show your work, so I can't. I can show you, or I wonder if it can. Let's see. So here is my calculator, and you can see their equation right there, 2x cubed minus 2x squared minus 8x plus 8. And then you plug it in, you put graph, and there you go. You see the graph right there? Does it look the same than when I did? Then you're right. So that's one way of double checking your work. If you're not confident in how your graph looks, use your calculator. It's not really cheating. I mean, you're just double checking your work. So yeah, that's about it all. Hope you all have a wonderful day, and I hope this video is helpful to some of you. Give me feedback if how I can make this video a bit better, or comments, maybe questions. I don't mind. Well, see ya. Have a great day. So embarrassing.